doesn't seem to do anything that's really that useful. Using this subroutine in the main subroutine, define submain, I can do the same thing here. I can have a local variable called point, and it is a coord. And this time, instead of using point.x gets a value, point.y gets a value, I can invoke the subroutine to do exactly the same thing. In other words, I can say invoke init coord xy, and this time I can specify the argument of point to specify the parameter c. I can use 50 to specify x, use 0 to specify y, and define sub invoke main. Does everybody agree that these two programs would do exactly the same thing? And let me just use also ... here to represent there are more stuff to do after this. Is everybody convinced that these two programs will do pretty much exactly the same thing? Okay. And it looks like the second version is just unnecessarily tedious. It is how many lines longer? It is 6 lines longer. And yet it does exactly the same thing. And even worse, if I read the second program, the one that is untitled at this point, it seems like it is just troublesome because when I read the main subroutine, in order to find out what init coord xy is going to do, I have to go into the definition of init coord xy just to find out what it does. Whereas in the original program, no ADT, I can see right away inside the main subroutine exactly how I want to initialize point. Right? So it would appear that no ADT is better than the one that is using ADT. So I'm going to save the second one using the name of ADT. So I will just say this one is the ADT version. How many people think the first one is better? Okay, you don't have to raise your hand. And just remember your choice, okay? Which one do you think is a better version? So the next thing we want to do is to talk about televisions, TV or display technology, which seems to have nothing, absolutely nothing to do with what we are talking about here, okay? So we want to go back in time and take a look at, different types of TV technology, just for the visual effect, so that we can, see all this stuff here in the video clip. Let's go ahead and go back in time and talk about the CRT, or the cathode ray tube. How many people still have a CRT type of monitor or TV at home? What do you use it for?
TV in the bedroom.
TV in the bedroom. So you have a HD TV converter or receiver on top of that, or do you just use it to watch VHS or DVD?
No, it's just a standard DirecTV box.
Oh, okay, so you have DirecTV, so that's why you can still use it, because it would not be useful to receive a broadcast signal anymore. Okay, so I'll just kind of go through a little bit of the technology, and let me see if I can find a good picture of. Yeah, this part is the best. Okay, the best explanation. So what happens is we have what we call electron guns. They're basically heated filaments. Okay, they're heated to a certain point, and it is charged with a really high voltage to the negative side. Okay, electrons also have a negative charge. In other words, we are strongly encouraging electrons to get out, with the part 1, which is called an electron gun. 2 is an electron beam, which is emitted from the electron gun itself. Focusing coils, which is part 3. That's basically that's why a television is so heavy in the good old days, because the entire tube itself is one gigantic vacuum tube. Okay. And the glass has to be really thick to make sure that it doesn't get crushed by the atmosphere. Component 3 basically will focus the electron beam into tiny little beams, And then you have number 4 deflection coils. Basically, it can redirect the beam to go to the left, to the right, to the top, to the bottom. And then when the beam hits the screen, the fluorescence material will basically emit visible light when the electron beam lands on it. Okay? So in order to increase the brightness, what do you do?
Turn up the voltage.
Crank up the voltage, exactly. Okay? And in order to, okay, so that's what you need to do. How many people at one point, had a CRT type television? It doesn't have to be today, at some point, maybe 5 years, 10 years ago. When you need to change the brightness of the picture, do you have to open up the television, find out which part of potentiometer, affects the overall, voltage, and tweak it, and hoping that you don't get zapped in the process? No one? How did you change the brightness?
A dial.
A dial. And later on, we use a remote control, right? You have a remote control and what we call OSD, on-screen display, to change the brightness of your picture. Is that right? Okay. And I can do about the same thing here with this. I just want to illustrate what I mean by using an on-screen display. Obviously, this part won't be captured in the video that I'm going to upload. And I have to go and find your menu. And you can just go to brightness here, and then I can change the brightness. Okay. So you're telling me that even back in the good old days with CRTs, some of the remote controls have features like that already. You can do the on-screen display and change the brightness, right? Okay, very good. So let's go ahead and get rid of this one. How many people have a LCD TV now? Just about anyone, right? I mean, that's the current TV technology that is the least expensive one and also most effective. And this is how it works. Okay, I just want to show you guys all the details of how a display works. It's not really that good of a picture. So basically, if you want to look at how it is designed, you have a light source to the back of everything. And the first thing is a polarizer. Okay, a polarizer basically means that only light waves spinning in one direction can go through, and the one spinning in a perpendicular direction cannot go through. So everything that can get past here has to be in a particular orientation, because if you're in the other orientation, it won't go through. And then what you have here is the LCD, the actual liquid crystal, component. Each pixel has 2 little plates. Okay, they can have a charge. If there's no charge, okay, if I explode this part here, if there's no charge, okay, so this is one electrode and this is the other electrode, and in between is what we call liquid crystal. If there's no charge, the liquid crystal will be somewhat random. In other words, it will let light through because there's no particular orientation to the liquid crystal. On the other hand, if you put a charge across these 2 sides, then all the crystals will align in a certain way. And when they do align, that means a certain type of wave, if it is in this orientation, it cannot pass through anymore. But remember, we already blocked all the horizontal waves. So anything that's getting past the polarizer is already in a vertical orientation. When we energize a pixel, even the vertical ones will be blocked. So what do you see on the screen? You see black, okay, because no light can get through. When I release the voltage here, when there's no voltage, then you see a white pixel or a bright pixel, depending on whether it's RG or B, but you see the primary color getting through. And that's basically the whole idea of an LCD display. So that means if you want to change the brightness, the first thing you want to do is to change this guy here. In other words, you can crank up the backlight. Back in the good old days, it's a fluorescent tube, and these days it's mostly LEDs, right? So what was the last time that you have to open up the back panel of a display like this, find out which part to tweak to change the brightness of the backlight? You haven't done that? And you guys are you telling me that you can change the brightness of your TV or of your monitor without having to open up the case? And all this time, I was trying to find out which part to tweak in order to change the brightness of my display. So what did you do to change the brightness? You use a remote, right? Now, when you use an on-screen display, of your remote control, does it say something like change backlight intensity or change the current going through the LEDs of the backlight? No? Does it mention anything about the bias voltage of the LCD? No? What did it say?
Brightness.
Just brightness, huh? Well, it seems like we have found something common between a remote control for a display and programming. Now, just as a last example, what you're seeing on the screen here is not CRT based and is not LCD based. Okay, this is a projector. And with a projector, it has an entirely different mechanism, especially with this one. This is what we call and I can't remember the name of that. It's not an LCD based, it's a reflective technology. I just can't remember the name of that. It's a technology of, I think it's Philips. DLP, thank you. Digital light processing. So the way it works is entirely different. You have to control the backlight, and also each pixel is basically one little thing on the chip itself, and it can change the angle by the voltage. And that's why we can see black, white, and etc. Okay. What is the remote control? It's an abstraction. Okay? It is an abstraction. What is an abstraction? I mean, that's a fairly uncommon word to use in daily language. What is abstract? What makes something more abstract than others? Okay, let's say you compare paintings, okay? So you're comparing, let's say, Ansel Adams' pictures to an abstract painting of exactly the same thing. What would be the difference between those two rendering of exactly the same object?
Distortion.
Okay, one has more distortion, but not with Ansel Adams. Ansel Adams' pictures preserve as much details as possible, right? You see, every single leaf, you see every single branch of a tree. But when you compare that, say, to an impressionist painting, the impressionist painting is not going to represent every single branch and every single leaf. It will preserve the overall look and properties of a tree, but other than that, things are a little fuzzy, right? So abstraction is basically losing details that do not seem to matter. Okay? And why do you think I call the remote control of your television or your display an abstraction? What am I losing here? What is the detail that I'm losing?
The display.
The actual mechanism of the display. Okay? In other words, the technology is quote-unquote abstracted. To the manufacturer, to Samsung or to Sony, they have to understand everything about how to control the backlight of your LCD TV. They have to understand how the amount of current passing through the LED would actually change the brightness. They have to understand all that stuff. But to you as a consumer, you don't have to understand that at all. You just have to understand what is brightness, what is contrast, what is color temperature, and so on and so forth. But you don't have to understand the technology behind the display. So your remote control is hiding all the technical details so that you don't have to deal with it. Am I doing okay so far with the concept of a remote control as an abstraction? Okay? It's taking away all the details, all the technical details that you don't